So we're really just looking at another component of this. So this is on page 32 of our booklets here. Excuse me. I'm just going to take a sip of water and we'll get up and running. Okay. So we're going to start off with direct linear relations. Now, if we remember, a direct linear relation is where it goes through that origin. It's a straight line and it goes through that origin. So it's a direct linear relation. That's where we're starting out with here. We already know how to find the slope of a line. This is given to us. We've used this a lot already. But when we have a direct linear relation, we can simplify this to y2 over x2, right? Because it goes up at the same rate. It's going up at the same rate. It's your rise over your run. But a really good idea is let's just take 2 points, use this top formula here as just a precaution here. So we're going to be introducing you to a new formula. And if you recall from your formula sheet, you don't have it. This is a really important one. There'll be an add-on to this later, but this y equals mx, really, really important. Now we know what all these 3 things are, right? So I'm going to recommend you guys put this into your booklets as well. So there's 3 things here, right? Y, m, and x. What's y stand for again? Starts with an R. It's rise, right? Rise is the y axis is going up and down, right? That's rise. We know that x then would be run, right? Going left and right. And we also know what m is, right? M is our slope. So none of this is new to us. So none of this is actually new to us. We know what all 3 of these things mean. So we can use this equation to calculate things. If I know 2 of these things, let's say, for example, I know what the rise is and I know what the slope is, but I don't know what the run is, I can use this equation to do that, right? It's algebra. If I know 2 of the 3 things, I can always find the third. So this is what it's all used for down here in this little box here. We're gonna practice all of these skills, but basically, if we can use this to calculate the slope, if we know a point, an x and a y on it, we can use it to find a y value. If we know an x and a slope, we can use it to find the x value. If we know the y value and the slope, that's the fancy way of saying if I know 2 of those 3 things, I can always find the third, right? It's algebra. That's what that means if we translate that from math to plain English. You have 2 things, you can always find the third using algebra. So let's try this out. So we have an example here. So for this example, we're going to calculate the values of y when we have an x from -2 to 2. So this is our equation. We are given an equation here. We want to figure out what the points are from this. So the first thing we want to do is we're going to want to draw a graph of it. Now, how do I draw a graph? What's the first thing I probably need? Label. I need to label it. So this is my x and this is my y down here. But now what do I do? I need a table, right? To draw a graph, I need data points. So what am I going to do? I'm going to make a t-chart or a table of values, right? So I'm going to quickly make a t-chart up here. I'm going to put my x. I'm going to put my y. So it wants me to figure out what y is if instead of x, I put -2, -1, 0, 1, and 2 in there, right? So those are the values I'm all going to put in here. -2, I'll make this bigger. -2, -1, 0, 1, and 2, right? So what is this asking me to do? This is asking me to substitute the values, right? So it's asking, hey, what is this going to equal if instead of an x there, you put a -2? Well, that's just going to be 5 times -2, right? Calculator can do the heavy work there for you. That's -10. So that's what it's at. So I know that when I have a -2 as my x, it's going to be -10 on a y. So I know that, so my coordinate for this one is basically going to be, x is going to be -2, and then y is going to be -10 is where this is going to actually be. Yeah. So you're going to notice, like, you might notice like this part here, I'll highlight it. Like, what the heck is this? This is just me showing how I got -10. You do not need to do that every time. I'll do it once more here, but 5 times -1 is going to give you -5, right? You don't need to write that in. I'm just kind of showing this because it's an example. Now, what's 5 times 0? 0. What's 5 times 1? 1. Oh yeah, 5. And then, 5 times 2 is obviously 10, right? So this is showing the x coordinates and the y coordinates. I now have plots. I can use that to generate a line. So let's do that. I label it. I have my x, I have my y. I have no, like, I can figure out my scale in here as well. Now, in this case, what we're going to actually do is, I'm going to zoom in just a little bit here. So we have our normal 15. Now, most of the time, we've had a graph that kind of goes like this, right? But it's always been positive. Or if it's been negative, it's still been in this quadrant. But actually, you guys have probably seen something that looks like this, right? This is a full coordinate plane. We've mostly just focused on this part up here. So now we're taking a step back. We're zooming out a little bit. We're looking at the whole thing, right? Because this is still my x-axis. This is still my y-axis. If I have a negative x and a negative y, it's somewhere down here, right? So I'm just going to clean this up a little bit, and we're going to clean this up a little bit, and then we're going to put this. So what I'm actually going to do, I'm going to draw a nice straight line down one of these lines, straight down the middle. And then it's the same thing. I'm going to go through the middle again. And now I've turned my 1 coordinate plane into a 4 coordinate plane, right? Now I have all 4 of those planes. But now I still do it, the rest of the graph, the same way. I still figure out the scale in for it, right? So if I have to go up a total of 10 and 10 on my y-axis, I'm probably going to say that, I don't know, I'm going to go up by 2s each time, right? So this is going to be 2, 4, 6, 8, and 10. This is my y-axis. This is my x-axis. This if I'm moving along this line here, this is still positive, right? Positives x's. So why don't I say 1, 2, 3, and 4, just because I only have to go up 2 there. But I'm not done yet, right? I can still go negative on this x-axis. I can still go negative on this y-axis. So now all I have to do is I have my scale in here, right? Now all I have to do is I have to plot my points. When I have an x is -2, my y is -10. So I'm going to go along to -2 on my x, and then I'm going to go down to -10 on my y, and that point is going to be right, make that bigger. Right here. I'm going to keep doing that. when I have an x of -5, my y is -5. So I go to -1 on my x-axis, and I go down to -5 on my y-axis. And that's just going to just repeat here. When I have an x of 1, it's 5. When I have an x of 2, it is 10. So we can use all 4 coordinates here. I'm going to quickly draw a line through that. It's going to look something like that. I'm just going to zoom out a little bit so everyone can see. Oh, I see a chat. So I just really quickly want to zoom back up to this wording though. Like, what did this question ask? Because typically most people tend to be confused as what the heck am I actually supposed to do? It wants you to find the values of y for when the integer values of x range from -2 to 2. So find y when you have these x values, right? -2 to +2. That's what it's asking you. A lot of math is just translating the math into plain English. That's what it is. So with that, I'm going to give you guys 5 minutes. I'm going to get you to try this. This is an equation here, right? You have y equals -4x and y equals 4x. So it's going to want you to calculate the values of y for the values of x that are given in the table. Now you're going to notice, what do you see here in these values? We usually try and stick to really small values. We use a couple negatives. We use a 0. We use positive ones. That usually gives you a really good idea of what the graph's going to look like. You don't need a lot of points. And it's a good idea to range a couple of those in there. And again, if you're not so good with negatives, like what do I need to do with that? Your calculator can do the heavy work for you. Like for example, for this first one here, y equals -4x, and you want to know what x is -2. Your calculator can do the heavy work for you, right? -4, not -4. Use the negative button times -2. It's going to be a +8 here, right? Your calculator can do that heavy lifting for you if you're not so good with negatives. So it's going to have you, though, draw both of these equations on here.
So then probably like 2 different colors.
You could use probably 2 different colored pens, yeah, or something like that. So I'll give you guys like, I don't know, 3 or 4 minutes or so. Try out both of these, calculate your values, ask for help if you need it, and try and draw your graph. And remember, you're probably going to have negative numbers here. It's probably going to be a 4 quadrant one. I'll get that recording back up and running. So, like I said, so that's my graph here, right? At this point, that should be a skill we're pretty good with. That's not the main goal. The main goal of this is we want to be able to understand slopes and we want to understand equations. So starting with this first one, this slope. What is the slope of this?
These are five. So the m equals y2 minus y1.
Yeah. So we know how to find slopes or something, right? This is what we've spent 2 days doing. It's y2 minus y1 all over x2 minus x1. But what I'm really looking for here is I want to know how much does it rise for every one that it runs. Now, because this is, and this is important, a direct linear relation, it goes through this point. This is the one and only time where you can just look at it. How high up did it go for every one that it ran? 1275. The slope in this case would be 1275. If this was a non-direct one, I would have to do this. So you can save yourself some work if you know what you're doing. If you are ever unsure what you're doing, just do this equation and it will give that to you. It's a little bit more work, but it will always work for you. But it would be, yes. Yeah. So in this case, I already know just by looking at it because it is a direct line. It goes through that origin. I know that it just goes up 12.75 for every one that it runs. I really recommend, first off, this by itself, this highlighted part, is a correct answer. You are correct. I really recommend get in the habit of writing that little invisible one. It will help out in the future if you do that. It's really important to always understand that that's there because that is your saving grace sometimes for questions is, oh, right, there's this one here on the slope. I can figure this out. So that's what our slope is. We know this. Now, my question for you is, what's our equation for this? That's question C, question D. I want to know what my equation is. So first off, what's my blank? I still solve it the same way. What is my blank formula for an equation? Y equals mx. It's always going to be y equals mx. That's my blank formula. We still solve it the same way. What's your formula? The next step has always been the entire course. What's your formula? Step 2 is, any guesses? Substitute. I know something in here. I know that my M is 1275. I know what that is. I'm gonna type that in actually. So I'm going to start substituting stuff and I'm just going to start here. You don't need to write this down just yet if you don't want to. I'm just kind of going a piece by piece at a time. 1275 is my slope. And because it's a really good habit, I'm going to put over 1. So I know what my slope is. Now, in all the other formulas, I'm just going to scroll up a second. In all the other ones, the y and the x kind of stood the same here, right? So technically, my formula here is y equals 12.75 over 1 x. Technically, this is times x. This is what my actual formula is. But my question for you is, what does the x represent? So this is my run, right? My run in this case is the 1 here of my slope. But what does the x represent on our graph? Well, it's how many hours she worked, right? So this is the fancy mathematical way of saying it's, hey, your slope times your hours, right? That's what this technically is. Oh, a bit. So that's what the x means. But technically, this is our equation. Y equals 12.75 over 1 times x. That's my full equation there. And that's fine. And then if I just know an x or I know a y, I now have 2 things I'm finding the third thing, right? That's exactly what we talked about earlier. So your first step has always been formula. Your second step has always been to substitute. Now, the final question here that they gave us is use this equation to calculate how much money she's going to earn in 5.5 hours. In that case, well, I know what that is, right? In 5.5 hours, well, I'm trying to figure out how much money she makes. That's my y value up here, right? So I'm trying to figure out how much money. So how much money or y is equal to, same thing, I'm just writing my formula, 12.75 times X. In this case, I'm saying, hey, instead of X, I'm going to put 5.5 hours. Yes. Again, this little times here, this is invisible. This is technically right here. I don't write that all the time though, because doesn't that get confusing? XX, that gets confusing, right? We're mathematicians, we're lazy. We do some invisible stuff. So 12.75 times 5, my Y, which is my money earned when I work 5.5 hours, which is my X, is going to be 12.75 times 5.5. That's going to give you $70. And round that to cents, it's going to be 13 cents. And that's my final answer. I'm always going to circle it. So now we know how to make equations and we know how to use equations. That's the primary goal that we have today. I'll give you a second just to get that all down. Okay. So, like I said, our main goal here is one, we want to learn how to make a formula, and two, we want to learn how to use the formula. So we've done that between question D and question E here. So I'm going to give you guys a chance here to do that. And you're not given a lot of information, right? It's draw a graph that shows the relationship and then find the slope, write an equation, use the equation. So I'm going to give you guys a couple minutes here, try question 2. I'm just going to blitz the answer out in a minute or two. In 2 or 3 minutes. If you're not sure what you're doing, please ask for help. I'll give you a hint. I keep forgetting to resume that recording. So what I'm going to give you guys is I'm going to give you about let me think here. Yeah, I'm going to give you guys about how many questions there? There's 1, 2. I'm going to have you guys do that one. 3, 4. I'm going to give you guys about a half hour here to try all these questions up until page 41. So you'll have till about 2 when we come. You'll have till 2:15 because we have our break after at 2. So basically, you're going to work on the next couple of questions up until page 40. Did I say 2? Up till page 41. So work on all these questions, including the example that's below. And we're going to come back at 2:15 to learn our final part of this. And then you're going to be given your first assignment, actually. Yay, everyone loves assignments. So I'll give you guys a little bit of time here to try these out. This is your time to practice this skill. Ask for help if you need it. You're meant to struggle a little bit. The more you look back in your notes as you work through this, the better you're going to learn. I'm happy to help, of course. Please ask for help. But again, part of the learning process is struggling a little bit. So we're going to get up and running here. We're just going to add one final piece to this. So I'm hoping that, if you guys went through this, it seemed good. Didn't seem like we had a lot of questions. It seems like we have a pretty good understanding of the Y equals MX thing, right? We're going to add one more thing to this. I'm just going to scroll down here to page 41. So we're just going down to page 41 here. And so now what we're really focused on is we're going to be focusing on this. Now this right here, what I'm highlighting is your God equation. Y equals MX plus B. It is used a lot. I'm in a college class right now and it's being used in that too. So this is a really important thing here. We know what the Y plus equals MX is. That's just what we looked at. The only thing that's new now is this B. And this B is something we call the Y-intercept. And I'll explain what that is in a second. So what is this y-intercept? So right now, what we've been doing a lot, you don't have to draw this, but all the graphs we've been doing today have been direct linear relations, right? They've been going through that origin. The only thing that's changed with them is the slope, but they've always started at 0, 0. This y-intercept is showing where it crosses the y-axis. The y-axis is the one that goes up and down here, right? Specifically, when we add a y-intercept, it changes it from a direct one to a partial one, is really what it's boiling down to. That y-intercept just changes how high up or down the graph goes. It is showing where it intercepts the y-axis. So the point at which the line crosses the y-axis is called the y-intercept. So that's the important part here. So that's the only thing we're adding here is the y-intercept. And that's just taking your same graph and it's moving it up and down. So to give you an example here, so I'm going to take one of our equations from up above. I'm going to take that y equals, where's that y equals 4? I'm going to use y equals 4x. So I'm just going to a graphing calculator right now. This dude does some of the hard work for me. Y equals 4x, right? That's what we've been looking at here for a bit. Now, what happens if I add a y-intercept? I can make that whatever I want. What happens if I add 5 to it? It moves up 5. What happens if instead of adding 5, I take away 5? Ooh, the same graph just moves down 5. If I add 0 to it, nothing changes to it, right? It's the same graph here. If I add 1.5 to it, it just moves up 1.5 on my y-axis. That's what it does. That's the goal of this y-intercept. It just moves it up and it moves it down, and that's all it does. So we're going to try this out. So we're going to write an equation for a line. It has a slope of 5 and a y-intercept of 6. So this is asking you two things. First off, this is asking you to write an equation, and then it also wants us to use it. What is the value of y when x is 5? It's really a really important skill is reading what the question's asking. This is asking you to do two things. So we're going to do those two things. So question A, I solve it the exact same way, right? What's my formula? Y equals mx plus b. And again, if you're ever unsure, you can always default to this, because worst comes to worst, the b is 0. And it just equals up to the same thing. Now, the only difference here is now I'm substituting stuff. Do I know what my slope is?
5.
Yes. So my slope in this case is 5. I'm going to put that little invisible 1 there. It's a good habit to have. X. And then do I know what my y-intercept is?
6.
6. Now, I'm going to put that in brackets here, because that's going to kind of come into play later when we come to negatives. This might make no sense right now, but like if you're adding a positive, you know, if I'm adding a positive, technically this is really just going to give me y equals 5/1 x. Technically this is plus 6. So this is what my equation is. I've made an equation. All I need in my equation is two things: y-intercept and slope. I don't care what the y is. I don't care what the x is, because I just use those to find different things. So all I care about is what the slope is and what the y-intercept is. And I'm literally going to write that down. What's the slope? What's the y-intercept? output, that's B. And this one's M. That's all I need to make a full equation now. So now the next thing it wants us to do is, remember this is a two-parter, is what is the value of y when x is 5? So basically, I can always use an equation. If I know everything about an equation except a single thing, I can use algebra to solve it. So the second part of this is, what happens if instead of x, I replace that x with a 5? Let's find out. Yeah. So I'm going to write that over here. I'm literally going to write my same equation, y equals 5 over 1x. You could just write 5x. And actually, I'm going to do that in this case. 5, instead of x, what am I putting in place of it again?
5.
I'm putting a 5, specifically a positive 5. 5 plus 6. So all I'm doing now is, well, 5 times 5 is 25 plus 6. Y equals 31. So this is the fancy way of saying is, hey, when I have an x of 5, I have a y of 31. If I was to plot this on a point, I would have this coordinate. That's what's going to eventually come up from here, is you're going to eventually learn to plot stuff, but that's what you're doing here, right? Just like we had that big table of values with y equals 4x, that's what you're doing here, just with that extra step. So I'm going to give you a second here. I want you to try out question B. I'm going to give you like, I don't know, like a minute. Try it out. You're going to notice here, what's harder about question B though? Negatives. It's the exact same style of question. The only difference is there's negatives added to it. So try it out. If you're unconfident, you can try it on loose leaf 2 or try it in pencil. It's okay to try. So I'll give you a minute there. Try out question B.